Bismillahirrahmanirrahim. We have discussed two-way analysis of variance, and in fact, in the previous lecture, we briefly discussed this issue. And today, I want to solve one example which would further clarify the idea that how we use two-way analysis of variance to solve some particular situations. Let us see, this is an example from your book. Basically, this is question number 17. Japan Manufacturing Company operates 24 hours a day, 5 days a week. The workers rotate shifts each week. Management is interested in whether there is a difference in the number of units produced when the employees work on various shifts. A sample of 5 workers is selected and their output recorded on each shift. At point 0.05 significance level, can we conclude there is a difference in the mean production rate by a shift or by employee? So basically, if you see, uh, there are two things involved. One is you can see days, day, afternoon, and night. These are the shifts. So shifts are involved. And on the other side, if you see, workers are involved. So these are the names of the employees. So the, the question is that can we conclude there is a difference in mean production rate by shifts or by employee? So let's say this is the day shift, and if you add all these values and you find out the average, and similarly, these are the productions that are during the afternoon shift. So we add these and find out the average production, and similarly these values. And if you add the values that are written in the rows, for example, 31 plus 25 plus 35, so definitely for these three there will be some other mean. So means on average, you will have some average for this, you will have some average for lumps, some average for Clark production, some average for trees production, some average for Morgan production, like this. The question is this, that there some difference in the mean production rate by shift. Let's say if it is up to shift, there is no explanation or requirement regarding employees. So if the question stops over here, is there a difference in the mean production rate by shift? So you will take only the data that are there in form of shift. So you will discard the employee, this title, this column. Okay, and in that case, it will be one-way ANOVA, for which we have solved several examples. And when you will incorporate the effect of employees, then it will become two-way analysis of variance, because now from two ways you are looking into the situation that whether there is some difference in the mean production because of shifts or by employee. So separately you will check, and the methodology that how will you solve it is like this. Let us start solving this. First of all, there will be step one. What is step one? Null and alternate hypothesis. And remember that in this case, we would set the null and alternate hypothesis in this way. H naught, and you have to put a bar on this like this. This will be your first null hypothesis. And against this, you will write down alternate hypothesis, but H naught bar will be mu dot 1. Mu dot 1 is equal to mu dot 2 is equal to mu dot 3. So we solved another example in the previous class where we saw a PowerPoint slide and I set the hypothesis in this way. H1 bar. This is the alternate hypothesis. And here you will write down there is no significant difference. There is no significant difference. So if you see, this dot means rows and one, this means column. So 1, 2, 3. It means that we are talking about treatments. Those are three in total. 1, 2, 3. So it means that the first null hypothesis is about shifts. So you can say that mu dot 1, mu dot 2, mu dot 3. These are the average productions during the shifts. So you can say average production during the day shift. Mu 2 is the average production during the afternoon shift, and mu 3 is the average production in the night shift. So definitely day shifts are several, afternoon shifts are several, night shifts are several, but we have taken sample. So you can say that we have simply taken these productions on odd days during day shifts. Okay, and let's say this 31 will mean that SCOF produced 31 units of that particular item during the day shift when he was, you can say, he was allowed to work in the day shift. When SCOF was allowed to work in the afternoon shift, he produced 25 units of that particular item. When SCOF was in the night shift, he was producing 35 units of production. So you can see apparently 35 units are being produced by SCOF during the night shift. So mostly production is there in SCOF's case when he is working in the night shift. So you have to see this question in this way. So three shifts are there, 1, 2, 3. So how will you write down the alternate hypothesis? There is no significant difference. There's no significant difference in production. In production, definitely on average, between shifts, as we are talking about shifts. So you write down the null and alternate hypothesis in this way. So this the null hypothesis means that the averages are same. No, this is not the statement. There is significant difference in the production on average between shifts. The word no is for the null hypothesis. Let me correct it. This word no is not there. The alternate hypothesis is that there is significant difference in the production on average between shifts. And if you see this, there is, as equality sign is there, it means that there is no significant difference. There is no significant difference between the shifts. Okay, when equality sign is there is no significant difference. When equality sign is not there, so alternatively you can also write it down as mu dot 1 not equal to mu dot 2 not equal to mu dot 3. So this will mean that there is significant difference between average production during the shifts. So now you have to set another hypothesis, and that is H naught and bar, or you can say double prime. So in this case, you write down, now you are talking about the employees, and employees are written in the rows. Okay. So you have to write down rows, let's say first row, and you are talking about, let's say this man, scarf. So this is the first row. First row will remain same and column will change. So it means that scarves production during the day. So mu 1 dot, mu 2 dot, mu 3 dot, like this. So in this case, you write down mu 1 dot. This is equal to mu 2 dot. Mu 2 dot means now we are talking about the average production that is being produced by lum. So lum is written in the second row and dot for the first column, and then lum's production in the afternoon. So 2 will remain same, and dot by dot we mean column. So column will be second column. So mu 2 2 will be there. Similarly, mu 2 3 will be there. So you have to write down this in this way. Mu 3 dot equal to mu 4 dot is equal to mu 5 dot. Why 5 dot? Up to 5 dot, because there are 5 implies. You can count 1 2 3 4 5. 5 implies are there, so you will stop over here. So these are the productions of, on average, by 5 employees. So now alternatively, the alternate hypothesis will be that these are not same. So mu 1 dot not equal to mu 2 dot, not equal to mu 3 dot, not equal to mu 4 dot, and not equal to mu 5 dot, like this. Or otherwise, if you are interested in writing it down, and better is that you write it down in form of a statement. So then you will write down it as, there is significant there is significant difference in production. There is significant difference in production between employees. Understand? Clear?
Yes, sir.
Okay, so an important, you can say, step where you have to set the null and alternate hypothesis. So now you will have to answer the question one by one. So first of all, second step, level of significance, and that is alpha equal to point. What was alpha? At 0.05 significance level. So you will write it down as alpha is equal to 0.05. This is the level of significance, and then you will write down step 3, where you will write down test statistic. And what will be your test statistic in this case? You will write down F1 calculated. This will equal estimated variance from, as you are talking about shifts in this case, so estimated variance from between shifts, so whatever estimated variance you will obtain from between shifts. Okay, so that will be the numerator in this case, and the denominator will be divided with the estimated variance from estimated variance from within within shifts. So within shift means you will take into account all those values that are there written in the table within shifts. So you for this you are considering all these values, and between shifts means between these two, and between these two, like this. From between shifts and from within shifts. So this will be your F1 that you will write down in this step, and the next is F2. And for F2, sorry, for F2, again you will write down estimated variance, estimated variance that will be uh, from between employees divided by estimated variance from within within employees. So from within employees, again all these values will be considered that are there in the question in this table. So it means that estimated variance from within shifts, whatever value you will obtain for this, the same value you will obtain for this from within employees, because in these two cases you will consider all those values that are there in the table. However, estimated variance from between shifts, this will be a different value, and estimated variance from between employees, this will be a different value, because once you will consider the values that are written in form of columns, and in second case you will consider the case where employees are being considered. In that case you will consider the values that are written in rows. So therefore the numerators will be different in both cases, but the denominators will remain same. And now there is step 4, and that is decision rule. Decision rule, and what will be the decision rule in this case? You can see F1. This is your calculated F statistic. If it is greater than or equal to tabulated or critical value that you will find at 0.05 level of significance, and new 1 and new 2. So what is new 1 in this case? New 1 is the degree of freedom for numerator. For numerator, and for this you have to subtract 1 from the number of treatments. So how many treatments are there? There are 3 treatments. I mean, there are 3 shifts. So shifts are being considered as these are in columns. So we are considering these as treatments. K. So K minus 1 is new 1. K minus 1 is new 1. And how many K number of you can say treatments, number of shifts? Those are 3. 3 minus 1. The answer is 2. And the other one is new 2. What is new 2? New 2 will be uh, how will you find out new 2? uh, K minus 1 multiply by R minus 1, multiply by R minus 1. So let us see how many treatments are there. There are 3 treatments minus 1. And how many rows are there, or how many blocks are there? There are 5 blocks. I mean 5 employees are there. So 5 minus 1. Fine. So this will be 2, and this will be 4. So new 2 will be 8. New 2 will be 8. For detailed discussion on this, you can see the previous lecture. So you have to see this. The answer is 8. So new 2 is 8. So now you have to see the table that is for 5% level of significance, F statistic table, and you have to see the value for 2 and 8. So what will be the value? 2 and 8. So let us see. Degrees of freedom 1, 2, and it goes up to 7. So this is not the relevant table. No, this is not. You have to move up to this table. This is 2 degree of numerator, and this is 8 degree of denominator. Degree of freedom of denominator. So here 0.05 and move rightward until you are here 4.46. So 4.46 is the critical value that you will take into your account. 4.46. So what this means that if my calculated value of F1 will exceed this value 4.46, I would reject H naught. So you can write it down as if F1 will exceed this, we would reject H naught. And the other decision rule that you will set over here is for F2, that is for employees. So again, in this case, F 0.05. And what is new 1 and what is new 2 in this case? In this case, you will consider rows, okay, because employees are written in the rows. So how many rows are there? Or we also call these rows as blocks. So how many rows are there? 5 rows. So R minus 1. R minus 1 is your degree of freedom for numerator. So new 1, what is new 1? R minus 1. What is R? 5. How many rows are there? 5 rows are there. Minus 1. The answer is 4. So that 4 will be written over here as degree of freedom for numerator. And what will be the degree of freedom for denominator? That will be again R minus 1 multiplied by K minus 1. What is new 2? New 2 is K minus 1 multiplied by R minus 1. So we have already found it. It was 8. So 4 and 8 is the degree or the degrees of freedom. So now again come to F table and see for 4 and 8. So 4 is here, 8 is here, 0.05 is this value. This is the level of significance. The value is 3.84. 3.84 is the critical value. 3.84. 3.84. So what you will write down over here, if calculated F statistic will exceed, I mean, if this is the situation, the first rule is this, that if this is the situation, then reject H naught. Reject H naught. H naught bar, I mean. And if this is the situation that F2 is larger than the critical value, what you will do? Reject H naught double prime, like this. So this is the decision rule that you will set. And then you will move to step 5, computations. So as you are doing things manually, so you have to write down a table. You have to write down a table. And as that will be a big table, so I am going to write down employees as not I'm going to write down their names. I am not interested in writing down these names. Okay, I can say that scarf means employee A, lum means employee B, this is employee 3, employee 4, employee 5, and day, shift, afternoon shift, and night shift. These could be written, or you may also write down day, sorry, shift 1, shift 2, and shift 3. So you have to write down a table that will help you in finding out those values that you will use to find out the calculated value of F1 and the calculated value of F2. So here write down employee. Let me try solving this, but I think there will be a problem of space. Employee, let's say employee A, B, C, D, and E. These are the employees, and then you have to write down the shifts. So shifts could be written over here like this, and there is day shift, then there is afternoon shift, and then there is night shift. Okay, and then you have to write down what you have to write down here: T I dot, T I dot, and then T I dot scare, and then submission. Here you have to write down J because you will add columns, whatever written in the columns, and X I J scare. Okay, and in the first column here you will write down T dot J, T dot J, because you will consider the values that are written in the rows, but the column will remain same. So I mean, first column will remain same, and you will see different rows. So you will add all those values that are there in the first column. And so I mean, the address of this is the cell address basically. So T dot J scare will be the next value, and the final value will be submission. And here you will write down I, not J, because you will be adding the values that are written in the rows. Okay, and scale is there. So now day shift, and you have to consider the values. So let me write down the values first: 31, 33, 28, 30, and 28. 31, 33. So if you have this question in front of you, you may help me. 28,
30,
30.
28,
What was the final value?
28,
Final value was 28. Fine, thank you. Okay. And then you have to write down
twen-
for
25,
uh,
26, 24,
25,
26,
26.
24,
24, 21, 26, 21,
sorry, 21,
26,
26,
35, 33,
uh,
30.
35,
Yes, sir.
35,
33 and next.
33,
30,
30,
28,
28,
27.
27. Right. So you write down it this way, and then what will be Ti dot? Ti dot will be the value that you will obtain by adding these values. So add these values to have Ti dot. If you have calculator with you, 31 plus 25 plus 35, 91. This is 91. So space issue will be there, but what could we do? As we don't have whiteboard, so there is a problem. So Ti dot square is 91 square. It is 8281. It is 8281. 8281. Right. The next value is for B, in which you will add these values 33 plus 26 plus 33. So simply add 33 plus 26 plus 33. The answer is 92. So let me write down these totals first. 92 for C, the answer is 28 plus 24 plus 30, the answer is 82. And then 30 plus 21 plus 28, the answer is 79. And for E, so you can use your calculator and reconcile these values. 81. These are the values. And now you have to add the values that are there in the columns to obtain T dot J. So add these values 31 plus 33 plus 28 plus 30 plus 28. The answer is 150. Answer is 150. And then add these values 25 plus 26 plus 24 plus 21 plus 26. The answer is 122. Again add these values. I think there is some issue. 25 plus 26 plus 24 plus, this is 21 or 29, this value?
21.
29. This is 29, not 21. So correct it. It is 29. And this is 29. So add these values 25 plus 26 plus 24 plus 29 plus 26, 130. Next. Everything I have to do, or you will add also? The answer is 153. 153. Similarly, add these values 919282. So add these values 91 plus 92 plus 82 plus 79 plus 81. What is your answer? I think there is a problem because we had added these three values and we took 79 as answer. We obtained this answer, but this is not the answer. What was the correct answer? Because this was 29.
It's 85, sir.
Sorry?
85.
Yes, sir. 87 आते हैं 79 की जगह.
87 is there, yes. Oh, I am unable to rub it. It is not rubbing it. I don't know what is the problem. Okay, then if it is not, you can say, accepting, or there's a problem. So it's upon you. You can consider it as 21. If it is 21, that this will not be the value. There will be a different value. And if it is 21, there will be different value. If it is 29, this will be the value. And similarly, you will change this value definitely when it is 29. So I am unable to rub this. I don't know why. Sorry, okay, it is there. So yes, what is the answer?
87.
87 is there. Fine. Now add these five values: 90, 91 plus 92 plus 82 plus 87 plus 81. What is that?
433. 433.
433. What is this 433? This will be your T dot dot. This will be your T dot dot. T dot dot means total of all observations. Right? So this value will be your T dot dot that you will use in finding out the correction factor. Okay. And then you are interested in finding out T dot J square. So simply take square of these values. 150 square. So the value is double two five. Sorry, double two five double zero. 130 square.
22,500. 150
Uh,
square.
130 square is 169 double zero.
Yes, sir.
153 square is
23409.
234
09.
23409. And there is no need of having square of this value. There is no need of having, so be attentive. There is no need of taking square of this value here in the table. In fact, you will add these values, these three values, and you will write down the sum of these three values over here at this point. So now add these values, this plus this plus this. See the answer. The answer is 62809. And now come over here. Ti dot square. So first value was this 8281. Then take square of 92.
4864.
8464. The next value is 82. Square for that is
6724.
6724. 87 square
7569.
7569. And square of 81 is
6561.
6561. Right? And now add these values. So add these values and write down the answer over here. See what is the answer. The answer is 37599. 37599. Right? So this will be your summation Ti dot square, and this value is summation T dot J square. That will be required when we will use the formula. And now what are these values? Summation I xi j square and these values summation j I j square. So for these values you have to write down the values in the braces. So the value, let me write it down. 31 square. Write down 31 square over here. 31 square. What is that value? 961. Write down in the braces. 961. Next value for this is 33 square. 1089. 28 square, 784. 30 square, 900. 900. Next value is 28, and 28 square is 784. We have already found it. 785. So now add these values. Add these values that are there in the braces. See the answer. And answer will be written in the first column. 961 plus 1089 plus 784 plus 900 plus 784. The answer is 4518. 4518. Okay. Then come to the next column. 25 square. 25 square is 625. 26 square is 676. 24 square is 576. 29 square is 841. 26 square again is 676. 676. Add these values that are there in the braces and write down the answer over here. 625 plus 676 plus 576 plus 841 plus 676. The answer is 3394. 3394. Then come to the final column. Write down over here 35 square. What is 35 square? 1225. 1225. 33 square is 1089. So some values are there in the table already. 300, 30 square is 900, 28 square is 784, and 27 square is 729. Add these values. So although there is some space problem, but what can we do? Add these values. On adding these values, what will be the answer? 1225 plus 1089 plus 900 plus 784 plus 729. The answer is 4727. 27. Now add these three values and write down the answer over here. 4518 plus 3394 plus 4727. 12639. 12639. 639. Okay. And now you have to add the values that are there in the braces and are written in rows. So first row, values are there in the braces in first row. So add this 961 plus 625 plus 1225 and write down the answer over here. Yes, what is the answer? 961 plus 625 plus 1225. The answer is 2811. 2811. 2811. Next, 1089 plus 676 plus 1089. The answer is 2854. 2854. Third one, 784 plus 576 plus 900. The answer is 2260. So you can check. I am quickly doing it, but you can check it. 60. Then next row, 900 plus 841 plus 784. The answer is, what is the answer? 2525. And next one is 784 plus 676 plus 729. 2189. That will be written over here. So in your answer sheet, you will write down these values fairly, not as I am doing. Don't mix things, okay? Because I have to write it down using my finger. So there is some problem and I have space issue, but on your notebook, when you will solve the question or answer booklet, you will write down things fairly, neatly, cleanly. Avoid mixing values. 2189, like this. So now add these values. 2189 plus 2525 plus 2260, 2260 plus 2854 plus 2811. See the answer. What is your answer? Let me ask you. What is your answer?
Wait, sir, we are doing.
2811. These values you have to add. 2811, 2854, 2260 plus 2525 plus 2189. What is your answer?
12109.
12109 will be written over here. 121 121.
09.
09.
It must equal this value 12639. If it is not equal to this, it means there is some issue. There is some problem. Again add 2811 plus 2854 plus 2260 plus 2525 plus 2189. 12639. Exactly same value is there.
Yes, sir. Yes, sir.
12139.
12639.
39. This is the value. As it value is not coming over here, so I basically you have to write down this value over here at this place. But I'm writing down over here because I don't have space. 12639. And here you write down check. Check will mean that these values are same. It means that calculations are fine. Okay, so now everything is there and you have to simply use the values. Okay, so I'm going to quickly calculate things. First of all, correction factor will be there, and the formula for this is T dot dot square divided by N. T dot dot square is this value. I have written over here T dot dot 433. So write down over here 433 square divided by N. N is the total number of observations. So total number of observations are, you can see 5 values are there in the rows and 3 values are there in the columns. So 5 multiplied by 3, 15 values are there in the total. 1, 2, 3, 4, 5, 1, 2, 3, 5 multiplied by 3, 15 values are there. So total number of observations are 15. So divide it with 15. So see what is the answer. Have you any other class after this class?
Yes, sir. Pakistan
At what time?
economic class, sir.
At what time?
Sir, 10:50, sir. 15, sir.
10:15. At 10:15?
Yes, sir. Yes, sir.
Okay. So we have few minutes and inshallah we shall cover. We will be able to cover it. Inshallah. So see, correction factor. This is the first thing that you will find out. Then you are interested in finding out total variation. Total variation that we also call total sum of square. So formula for this is summation I or summation j xi j square. So the same value was there when you considered summation I xi j square, or if you consider summation j xi j square, same answer was there. And you have to subtract correction factor from this value. So what was this value? This value was 12639. 12639, and correction factor you have just found 1249. 1249.27. This is the value. So see what is the answer.
Sir, 99 and 124. Correction factor.
Sir,
12499.
Yes, sir. Correction factor.
Sorry, 12499.27. So 12499.27. See what is the answer.
sir, minus 1237.
No
280.
minus. Positive value 139.73.
Yes.
Right. So this is your total variation. Now you are interested in finding out what is the variation between shifts, or you can also call it treatments. So between shifts, sum of square, or between treatments, sum of squares. Fine. So it's upon you. You can write it down in any way. So as shifts are there, so you can write down as uh, between shifts, sum of square. Understand? BSSS, or you can write it down as BTSS, between treatments, sum of square. So this will be summation between treatments. So treatments or shifts are there in the columns. So you will consider J. How J? I mean, you write down the formula as summation T dot J square. T dot J square, because this is the total for the values that are written in the columns. T dot J square, and you have to divide it with R. Why R? Because there are rows involved in the columns, so you have to divide it with R. 5 rows are there, and you have to subtract the correction factor from this. So all these values are there in the table. If you see summation T dot J square, what is the value for this? Summation T dot J square, this was the value 62809. 62809 divided by 5 minus correction factor was 12499.27. So see what is the answer. Help me, because we don't have time, and we have
Sir, 60,
6
62.53.
62.53. Right. So this is your between shifts variation between shifts. You will find it out in this way. And then there are employees. Okay, so between employees, you can write down E, or you can write down, if you consider employees as blocks, so you can write down between blocks, sum of square. But it's upon you. You can use E or B. Notation it is upon you. So I'm writing it down as E. Between employees, sum of square means variation between those values that are for employees. So for this summation T I dot square you will consider. Why? Because employees are written in the rows, and sum for rows are given in this column. Sum for rows, this value Ti dot, this is the sum for those values that are written in the rows, this value, and square of this is this. So summation for this is this value 65 this value is 37599. 37599. Okay, and you have to divide it with the in that case you divide with 5 because rows were 5, but in this case you will divide it with columns k minus correction factor. So columns, how many columns are there? There are 3 columns. Minus
3.
1 2 4 9.27. Okay, so see what is the answer. Quickly, boys.
Sir, 33.73.
33.73. Very good. So this is your variation between implies, right? Yeah, you have found the variation between implies. Now you are interested in finding out the variation within implies or variation within shifts. So it means that now you have to consider all these values, So that is a difficult task, but we can easily find it out if we consider the formula that is like this. Total variation definitely will equal the between shifts sum of square plus between employees sum of square plus uh, within employees sum of square or within shifts sum of square. So that will be a same value. So you can write it down as within sum of square. Within means within shifts and also within employees. Okay, same value will be there. So we are interested in finding out WSS because all other values are there. We have already calculated. So for WSS, you can transform this equation. This will be TSS minus BSS S minus BESS. So now write down the values and have the final value, that is variation within the shifts or within the treatment. So this is basically the we also call it residual sum of square or otherwise error sum of square. Okay. So see what is the answer. TSS, what was the value for TSS? 139.73 minus, what is the next value? I think you should write down these values on your notebook because sometimes we miss the lectures. Although we are recording it, but sometimes there are some issues. So better would be if you use your notebook, write down these everything on your notebook. 62.53.
43.47 आता है सर माइनस करने के बाद सर
2.53 minus, what was the final value?
33.73
33.73. So the answer is
4347 4347
43.47.
43.47. This is your error sum of square or within sum of squares. So now everything is there, and now we are able to write down the ANOVA table. This is the final step that you will do to find out the calculated values for F1 and F2. So ANOVA table, this is the table that you will finally write down. So here you write down SOV, source of variation. The next column will be degree of freedom. The next column will be sum of square. The next column will be mean square. And the final column will be F. Okay. So source of variation first is between shifts. The next one is between employees. The third one is within shifts or within employees, and then there is total. Okay, So write down in this way. Then write down the degrees of freedom between shifts. How many shifts are there? There are 3 shifts. 3 minus 1, k minus 1. The answer is 2. Between employees, how many employees are there? 5. So 5 minus 1, the answer is 4. Okay. And then come down to total. What is total? How many total observations are there? What is the value for n? 15 minus 1. 15 minus 1 is 14. 15 minus 1 is 14. And now subtract these 4 and 2 from 14. 14 minus 4 minus 2. So the answer is 8. The answer is 8. So that 8 will be written over here. And this 8 we have already obtained using k minus 1 multiplied by r minus 1. Okay. So this 8 may also be found using that strategy, or simply subtract 4 and 2 from 14 to have this 8. So degrees of freedom are there. Now these values between shifts, sum of square. We have found this value. What is this value? The value was BSSS 62.53. 62.53. Then next value was
33.73.
33.73. Thank you. Next value
4347.
43.47. Okay. And then finally total
139.
variation
139.73.
73. So you will write down the values in this way. And then mean square. Mean square for between shifts. Mean square value for between shifts. So how will you do it? You will take this value and divide it with its own degree of freedom. So this value divided by 2, this value divided by 4, this value divided by 8, and there's no need of dividing this value with this. So first 3 values only. So 6253 divided by 2, the answer is
31.265.
31.265. So you may write down 31.27. Round it off up to 2 decimal points. Next value 33.73 divided by 4.
8.432.
8.43.
Yes, sir. 32.
Yes, yes.
Okay. Next value. Error sum of square within 43.47 divided by 8.
5.433.
5.43. And there is no need of writing down any value for this, because that is not required in the formula. So here, first of all, you will find out F1. F1 will be this value 31.27 divided by this value, as we have written in the decision rule. What is this? Between sum of square, or you can say the estimated variance from between shifts. What is this? This is the estimated variance from between shifts. So you can write down 31.27 and divide it with this value, estimated variance from within shifts. 31.27 divided by 5.43. The answer is 31.27 divided by 5.43.
5.758.
5.759.
58.
So you can write it down as 6. 5.76. And what is F2? For F2, you have to take this value, estimated variance from between employees divided by estimated variance from within employees. So this is the same value. 8.43 divided by 5.43. What is the answer?
3.079.
Sorry. 8.43 divided by
3.07.
5.43. 1.55.
1.6.
1.55 if you take up to 2 decimal
Yes, sir.
points. Okay, so F1, F2 are there. So this is these are the two required values that we have to find out. As this procedure is not there in your book, he has followed some other procedure. So it's upon you. You can use that procedure also. But I think it is more easy. Comparatively, it is easier. So therefore I have used it. Easy to understand, easy to find things. So now you have to compare these values with the tabulated values. So what are the tabulated values and what are the calculated values? Right down over here, 5.76 for F1 and 1.55 for F2. So what was the values for F1 and F2? I think what was the value for F1? Tabulated critical 4.46 and 3.84 if I recall my memory. So 3.84 was the critical value that we wrote. So in this case, this is greater, and in this case, this is greater. So F1 rejected. F1 rejected. It means reject H naught bar. And in this case, don't reject. Don't reject H naught bar bar. Okay. So what this means, in the sixth step, you will write down the interpretation. Interpretation. So what will be your interpretation? In the interpretation, you will write down, what will you write down? You are going to reject H naught bar. And what was H naught bar? There is no significant difference in production between shifts. So you will say, yes, there is no difference in production between shifts, means it doesn't matter that which shift is there. There is no difference in shifts. You can write down, there is no difference. So what you have done, you have rejected H naught. Sorry, you have reject H naught means you have rejected this. Sorry, let me correct it. You have rejected this statement. This statement, you have rejected this. It means you have accepted this. So you can say there is significant difference in the production. There is significant difference. You are going to accept the alternate hypothesis. There is significant difference. There is significant difference. There is significant difference in production. Between shifts. Understand?
Yes, sir.
Yes, sir.
And in second case, don't reject H naught. Don't reject H naught means you are going to accept H naught bar bar. Exception of this will means there is no significant difference. There is no significant difference in production between employees. Understand? So this is the interpretation of the results. So this is all for today. Thank you very much for your patience. We have taken a few more minutes, but we have completed one complete example, and this will help you a lot because you have to write down things manually. And I have done the same similar calculations in Excel also, So now you are able to do things in Excel and as well as manually with your pen on your notebook. So this is all for today, and thank you very much for your patience. If you have any question, you may ask right now.
No, sir. Thank you,
No,
sir.
sir, no
Okay,
question.
thank you.
Okay.